Okay, this is the worksheet answers for 7.5. Go through them. This is a cubed, just in case you can't read it, and correct it. Make sure you bring it into class, and I'll look over it. Okay, there we go. Pause it if you need to. Okay, 7.6, exponential functions. Okay, so we see the word exponent in that. To evaluate and graph exponential functions. So the first thing we're going to be asked to do is to determine if something is exponential or if something is linear. And in order to be able to do that, we have to know what it means or what it looks like to be an exponential function. An exponential function is a function of the form y is equal to a times b to the power of x. Notice one of our variables is the exponent. That's very important. First off, a cannot be equal to 0. It could be positive or negative. And b has to be bigger than 0. b cannot be equal to 1. Okay? Because 1 to any power is always 1. So we wouldn't be dealing with exponential at that point. And x is real. Okay? Now what we have is we have two possibilities. Actually 4, sorry. If b is big, we're going to end up with one of these. Okay, notice if it's positive, we get it going up. If it's negative, we get it going down. That's the blue line. So each one of these is going to grow or get smaller. Okay, you notice that it never crosses the x-axis. Okay, so if it's basically like this, we're not talking about something crossing the x-axis. Here, the a is equal to 1. Okay. Now, if the b is a fraction, then we're going to end up the reverse in a way. Okay, you sort of see mirror images of each other. Okay, so it's a little bit different when a is a fraction. B, when b is a fraction. Okay, but notice that b is never negative. Okay, it's greater than 0, but not equal to 1. Okay, so let's look at the first type of question. Here, they're giving us a situation, and our job is to determine if it's linear or exponential. Remember, if it's exponential, it's going to have a variable as an exponent, so you should be able to look at one of these right now and say that one of them is or is not exponential. The other thing to do is to determine the difference between each value. So that's what we would do in this instance. We would realize that this is +1, this is +1, this is +1. So these are common differences. And common differences mean that it's growing at the same rate. So this one is linear, okay, because of the common difference. All right. What do you think this one is? Exponential. Because it looks like this. Y is equal to a times the power of times b to the power of x. Okay? All right, on to rabbits. We're given an exponential function. F of x is equal to 20 times 3 to the power of x. We're told that it triples by 20 rabbits. This is the beginning population, and it triples every year. Okay? We want to know, now, the tricky thing, gives the population after x half-year periods. So x is not the number of full years. Each x represents a half a year, 6 months. So we're being asked, how many rabbits will there be after 3 years? So 3 years is equal to 6 half years. Okay, so we're going to take 6 and plug it in for x. So f of 6 is equal to 20 times 3 to the power of 6. Okay. 3 to the power of 6 is 729. So f of x, f of 6 is equal to 14,580 rabbits. So 14,580 rabbits will be the population after 3 years, and we started out with 20. I once went to a campground where somebody had let out a pair of rabbits, and no joke, they had only been there 6 months and there were probably close to 200 rabbits. Incredible. Okay, last one, graphing. Table is going to be the easiest way to do it. Pick a few numbers. We start with those and work it out. So 3 to the power of 0 is 1, so this is 0.5. This is 3, so 1.5. This is 9, so 4.5. This is 27, so 13.5. Okay. And then we graph it. So we need 1, 2, 3. And then here I'm going to go by, let's go by 5s. 5, 10, 15. Okay. So 0 and 0.5 is going to look like this. 1 and 1.5 is going to look like that. 2 and 4.5 is going to look like that. And 3 and 13.5 is going to look like that. So what we're going to watch is that that's how it's going to grow. Okay. You don't have to pick these numbers. I would suggest a couple positives, definitely a 0, maybe a negative or 2, just so you see what happens. But we see the curve. Okay. So I'm going to let you go ahead and do that one. You should see something consistent with those two that goes back to the beginning. All right. This is section 6. There is, as always, a word problem at the bottom of page 455 that you can look at. It just kind of uses this topic, and instead of going over it, I just let you figure it out. Okay. Prepare, ask questions. Make sure you got your notes, all that good stuff. And I'll see you later.